One nice thing about a multiple choice test is you probably have to spend less time studying these types of problems than others, because instead of having to use the rational root theorem and Descartes' rule of sign and guess and check, you've got some answers sitting in front of you that you can think about. Like, for example, this answer right here is pretty stupid because 12 doesn't go into 45. And so it can't possibly be a root if the number doesn't even divide into the last term, because rational root theorem says that all the factors of the last term over the first term. So once you have kind of the dumb ones out of the way, you can look at, well, B and C both have -3 and 5, so I'm going to try one of those as an option. You are going to have to know how to do synthetic division, though, because it's going to be your friend, and it's going to let you check all of the multiple choice answers to see which one works. So if I drop the 2, I get 10, 3, 15, -9, -45, and 0. So this is x minus 5. You do have to know that the sign of right here of the 5 is opposite what it looks like in the factor, and you're also going to have to be able to take the leftovers and factor them. That's 2x squared plus 3x minus 9, which, if I factor it, will be 2x times x. I need to make the last term multiply to 9, and the outside and the inside together make 3. So I'm going to make this a positive 3. That will make the outside terms right here a 6x. And so I'm going to make the inside a -3. That will make the inside terms a -3x. And that will give me this 3x in the middle, because 6 minus 3 is 3. And so if I had to write the linear factorization for this problem, it would look like x minus 5 times 2x minus 3 times x plus 3. Oh, but it's multiple choice, so I don't have to worry about all that work. My factors are 5, -3, and 1.5 right there. Oh yeah, that was a dumb one. We're crossing it out. You will need to think about multiplicity, including kisses and shoot-throughs. For this problem right here, this is an x, it said which power it is. And if I look right here, I've got 2 x's here, I've got another x here, and I've got 2 more x's here. So I have 1, 2, 3, 4, 5 x's. So this is going to be some sort of a 5th degree equation. It could look like that. But in this case, we have to think about whether each of the zeros are kisses or shoot-throughs. And the zeros are listed below as part of the linear factorization. So you've got a 0 at 3, you've got a 0 at -1, and you've got a 0 at -4. So we'll make this -4, -3, -2, -1, 0, 1, 2, 3. And so this graph, because it's a 5th degree equation, has to generally go up. And the first 0 it's going to kiss. The second 0, -1, it's going to shoot through. And this third 0, +3, it's going to kiss. So you have to be able to translate a factored function into what the graph might look like. Obviously, I didn't show height on this at all. I just showed basic shape, and that would be the little kid in front of the piano video. Some of the multiple choice questions on the exam are matching the function with the graph, but a lot of them are just questions about intercepts. The vertical asymptote is what makes the bottom equal to 0. And for this first function, the vertical asymptote would be at x is equal to 3. For the next function, and a lot of you tend to miss this, this is squared, so it has 2 possible answers. So it has 2 vertical asymptotes at x equals positive and -3. This last function there's nothing that can make the bottom equal to 0, so this has no vertical asymptotes. And this is one of those graphs that comes out looking sort of like a lump. When determining the horizontal asymptote, you need to look at the powers. If the bottom power is bigger, like in this first problem, it has an x to the 1 on the bottom, but there's no powers of x on the top. So that means there's x to the 0 on top. So bottom power is bigger. It means the horizontal asymptote is at y equals 0. If the powers are the same, like as in this problem, then you look at the leading coefficients. And so 2x over 1x would have a horizontal asymptote at y equals 2. In this next example, the powers are the same, but the leading coefficient is 3x and negative 1x. So the horizontal asymptote would be at y equals negative 1/3. Now, we also did what happens when the top power is bigger. Those are slants or holes, but they're not going to be on the final exam. To find the x and y-intercept, you have to do the following. The x-intercept is what makes the top equal to 0. So for this problem, if I made 2 times 3 halves minus 3, that would give me 0 on top. And so the x-intercept is at 3 halves and 0. If I wanted to find the y-intercept, I would just make x equal to 0. And so the y-intercept would be at 0 and negative 3/4. So if you had to answer all the questions about this rational function, you would first look at the bottom. That gives you the vertical asymptote. This has a vertical asymptote at x equals 5. Then you would look at the powers. This has a power, this has the same power in the top and bottom. So you look at the coefficients. So I have 2x over 1x. And so this function has a horizontal asymptote at y equals 2. And then you look at the top of the function. The top of the function gives you your x-intercepts. So right here, if I made x equal to 3, that would give me an x-intercept at 3, 0. And then you look at just what would happen if you got rid of the x's altogether by making the x equal to 0. And if I scratch this one off and I scratch this one off, I would get a y-intercept for this problem at 0 and negative 6/5. So on the multiple choice portion of the test, you're going to have to answer questions about what the asymptotes and the x and y intercepts are for rational functions, in addition to matching them up with the graphs. The only step we haven't done in getting to the graph is when you make your table of values, you need to test points that are to the left and right of the vertical asymptotes. So like this problem has a vertical asymptote of 5. I would test the point 4, and I would also test the point 6 in the equation. And lastly, we'll look at some basic graphs and what happens to these graphs in terms of shifting. Here's y equals 2 to the x. I put in 0, I get 1. Put 1, I get 2. There's the y equals 2 to the x graph. If I were to put a negative in front of that graph, so take y equals 2 to the x, but I change and put a negative in front, that's going to flip the graph upside down. If I take the same graph, y equals 2 to the x, but I put a negative inside the graph next to the x right here, that's going to take the function and flip it across the y-axis, and it looks like this. If I were to take the y equals 2 to the x graph and add or subtract after it, let's say I'm going to subtract 3, that would take the horizontal asymptote at 0 and shift it down 3, and the function would then look like this. The two rules that students tend to get mixed up are when there's a negative in front, like this graph, that's what makes it upside down. The negative on the inside, this one takes the graph that was here and flips it sideways across over the top of the y-axis. So this last graph, square root of x, it is bounded below. It is an increasing function. Its domain is x is greater than 0, and its range is y is greater than 0. And if you were to take that function and put a negative in front of it, remember the negative in front is going to flip it upside down, so it'll look like this. If you were to take the same function and put a negative inside of it, that's going to take the function and reflect it across the y-axis. If you were to take that function and put, let's say, 2 minus x inside of it, that's going to shift the graph to the right 2, and it's going to flip it across the y-axis. And if I were to take that function and add 1, it would simply move it up 1. There are quite a few questions about how a graph is transformed, and they're all matching questions. So what you really have to know is how to make the base graph in the first place, because in order to do all the shifting and flipping and stuff, you have to know what the base graph looks like. You can have as much scratch paper as you need on the test. So if you had a question like this in the test, 3 to the negative x minus 2, and you didn't know exactly what the base graph looked like, you would just write out y equals 3 to the x, make a table of values. If I put in -1, I get 1/3. If I put in 0, I get 1. If I put in 1, I get 3. Figure out what that graph looks like. And then apply the rules we just talked about. So this graph would be shifted down 2, so the asymptote would move. But in addition to shifting down 2, it's going to be flipped across the x-axis. Sorry, flipped across the y-axis, and so it's going to look like this.